In this lesson, we're going to look at correlation and lines of best fit. Now, this topic here is normally for statistics, but because it has elements of what we saw in linear equations, we're going to learn about it here. Now, a scatter plot is a type of line graph that show if there is a relationship between sets of data. So here we see three representations taken from the textbook. And the first one, we see some dots. But you'll notice that these dots, in relation to each other in terms of the x-axis and the y-axis, or the independent variable with the dependent variable, have a common correlation that's happening there. It looks like it's going up in a positive slope direction. Whereas in the negative correlation, it looks like it's going downhill, as if the dots are going collectively down to the same area. But then in the last one, we see it's relatively no correlation because they're just randomly scattered. There's no real theme to it, there's no real direction. And so these are basically the three things that we use when dealing with slope: positive slope, negative slope, and basically zero slope or no slope, as it's not neither horizontal nor vertical, it's just randomly placed. So no correlation, we will state. All right, so let's do an example of one of those things. We're going to determine the type of correlation. So just looking here, does does the scatter plot at the right show a positive correlation, a negative correlation, or relatively no correlation? And just give an explanation why. All right, so we're just going to do that together. If you look at this, you see that those dots going from left to right, remember we read from left to right. And so when we write this out, we want to make sure we do the same thing, the concept. So remember, from left to right, as you go, just like we did before, you see that those dots are going in a positive correlated direction. And so that would be our answer. And our answer is, your explanation is basically, you're seeing that as you go to the right, as your x increases, your y increases as well. That is the very definition of the slope. Your rise over run is in a positive direction. Okay, so let's look at example 2. This lesson is going to be really short, as it's basically the same concepts that we were doing before. All right, so in exercises 6 and 7, this is from the textbook, page 103. It asks you to, this was one of the exercises at the end of the chapter, and it's for 6 and 7, and it says, which gives the number of FM radio stations from 1989 to 1995. And so remember, this would be 89, that's where you start, 1990, 91, 92, 93, 94, and 1995. All right, so we're going to look at these years and plot them. So first, we need to approximate the best fitting line for the data. So remember, just like how I drew a line through there, we're going to do the same thing here. We're going to plot the dots, and then we're going to draw a line. Now remember, for me, in order for me to properly sketch on my screen, a dot can sometimes be hard, so I might have axes. Just depends on how difficult it is. I still don't have a very viable ruler for this, so I'm just going to draw it by hand, and hopefully this comes out smoothly. All right, so first of all, I'm going to need 6 units from the x-axis. I only need the first quadrant because all of these values are positive. So that means we can use this line here, and that was pretty straight. And then we can go up vertically as well. My engineering teacher would have been proud of the bottom line, almost. All right, so we have 0 here, and we're going by 6. So we could skip 1 just to make it easier to plot. So we have 1, 2, 3, 4, 5, 6, and 7. That's going to represent our x-axis. We could just fill it out just to make it look complete. All right, now the y-axis, notice that it's actually going up pretty high. What we can do is a break. We could put a break in the line just to skip a few. And especially because if we went up by thousands, it's going to be very hard to graph because all of these numbers are separated by about 1500. And so we can start our, and I might have to erase this to do it again, but can I just erase a part? No, it erases the whole line. All right, so what we're going to do is draw an axis break. All right, so we're going to go up, we're going to do this, and then continue. and try to make a break. All right, so this means that we're at 0, and then the break starts, and it just means that we're skipping a few numbers. Just like in language arts, you have ellipses between like words. If I was quoting from something, I said the data is, it could mean that there's information in between. Same thing happens with that. If we have large amounts of data and we're trying to graph it, but the beginning data we don't need, we can put a break in the graph, especially for one like this. So now that we have the break, we're starting at 0. This next line could represent 4,000 and work our way up from there. So that could be 4,000. And I'm wondering if I should go up by twos. Let me see, 42, 44, 46, 48, 50, 52, 54, 56, 58. That could work if I go by twos. All right, so 4,000, this one here can represent 4,200, 4,400, 4,600, 4,800 is this line here, so 4,900, 5,000. Oh, I messed up there. That should have been 5,000 right there. Remember, we're going up by twos. That one doesn't want to erase. All right, so 5,000, 5,200, 5,400, 5,600, 5,800. All right, and we could just top it off there with 6,000. And this represents our y. So now we just plot our points. So, they're going to be kind of rounded, so these are going to be estimated values. So for the first one at 0, we're at about 4,269. And that's going to be relatively close to 4,200. So that's our first one. Our second one is at 4,392 because that's 4,400. It's going to be pretty close. Maybe I should change the color so it stands out. So that's our first one. At year 1, which will be 1990, 4,392 would be relatively close to 4,400. The second year, 1991, that's 4,570, which is pretty close to the 4,600. Now, if you want it more accurate, it's hard for me with the space that I have. But with you, if you would have went up by hundreds, if you were on a piece of paper, you could really have the space to do this. So instead of going up by twos, like 4,000, 4,200, you could do it by 50, 4,050, 4,100, 4,150, or you could go by hundreds. The more space you have, the more defined your graph and points can be. So number 3 is going to be at 4,785. Again, that's pretty close to 4,800. And I'm just going to put some more markers in here. Just makes it a little bit easier. And remember, use a ruler. For me, it's a bit difficult, but for you, you should be able to do it with pen and paper. All right, so at year 4, that's 4,971. Very, very close to 5,000. Would have been really nice if they just had rounded numbers there. All right, number 5 would have been 5,109. So that's just going to be a little bit above halfway, basically. Right? And you can see the points are not directly in line. They're slightly off if you look carefully. And like I said, if you were more refined, you'll see it more. And then lastly, number 6, 5,730 would be pretty high. 5,730 would be possibly about here. All right, so these dots are not in a straight line. If you should try to draw a straight line through them, you see they don't touch. But now that it's approximated, we actually need to come up with an equation now of a line. Now the way that we do that, once we draw the scatter plot, and you can find this on page 101, some steps to help you. You want to sketch the line that will be as close as possible through it. Now in this case, the closest line basically is going to run very close to these points. It may not touch that top point, and that's fine. But for the most part, you can see that these ones are pretty straight. Okay, so we're going to do a blue line there. And make sure you use a ruler, right? I should have possibly drew that closer to the points there. So just do that one more time. And your points might look slightly different if you do this with me. I'm going to start about here and come through. Right? I didn't want to draw through the points because technically they wouldn't be as close, but since I'm rounding, I'm just going to have the line slightly above just to kind of make it more realistic in terms of a more refined graph. Okay, so now that we have this line here, it's the line of best fit that is as close as possible to all the points. We just need to pick 2 points that are on the line. And we're going to assume that it's this one here and this one. This ones are the closest to the line. And so we're going to use those 2 points to estimate an equation to represent the line. So the first one is this one, and the second one is where it's at 4. So we're going to use those 2 points. So first we need to get an approximated slope. So we have m, and technically I could use the approximation sign there just to say that's the approximate slope. But we're going to use the equal sign in this case. So y2, our y represents the fm. So that's 4,971 subtract 4,269. All divided by 4, x2 subtract x1. Okay, so we can work those out. You can use a calculator. You could do that in your head. So we have 4,971 subtract 4,269. And that's going to give us 701 divided by 4. 701 divided by 4 is going to give us approximate answer, well, equal answer, 175 and 25 hundredths. All right, so that's our slope. And now we can use the point slope formula, or we could just use our understanding of slope-intercept form, but I'm just going to stick with the point slope formula. And that's going to be y subtract y1. And remember, you could choose either one of those, right? I'm going to choose the one with 0. That's just going to make the equation simplify easier. So y subtract y1. So my y1 in this case would be 4,269 is equal to m, our slope that we just found, 175.25, times x subtract x1, which in this case is a 0. Now remember, it doesn't matter which one you chose. We did that before, and we still worked out the same thing. So we can simplify this. You can either bring it over right away or simplify. I like to do them all in one step. So I'm going to bring over, and x minus 0 is just x. When we bring over the negative 4,269, it becomes a positive. And so it becomes plus 4,269. And so you have your y equals to mx plus b, and it's much faster than doing it with the other point. So then the last thing says, if the pattern continues, how many FM stations will there be in 2010? Now you can estimate this using the graph. Did we go that far is the question. 2010, remember, and you just basically one down, so you're looking for 1999. I mean, sorry, not 1999. You're looking for pretty far. And so since that's not going to fit, the graph, I was thinking 2000 when I first said it. Because 2010 won't fit on this graph unless we made a really long graph, the best option here would be to substitute what the value of 2010 would be. All right, so as we skip along down the years, what we're going to do is trying to get to 2010. You notice that at 1995, that's 6, right? It's always one down. So when you get to 2000, that's going to be 1 up, right? From 95 is 1 up to 6, so this is 1 up to 11 instead of 10. And if you were to keep on doing that, just to kind of help out, 2001 would be 12 years. And if we were to keep on going to 2010, instead of 20 years, that would be 21 years from 1989, which you could have just added anyhow. All right, so that's 21 years that we have. So we have y is equal to 175.25 times 21 plus 4,269. Now, these can give various different answers based off of each person's line, but generally you want them to be relatively close. All right, so we have 175.25 times 21 plus 4,269. About 7,949 and 25